What is the price of a 7-year semi-annual coupon bond with a 10% coupon rate if the YTM is 12% and the par value is $1,000? Okay. So the key here is that it's a semi-annual coupon bond, so we have to change the R and the coupon payment and the N accordingly when we do the calculation. Okay. So we'll do example 2. So I'll first put in the details. So we have a coupon rate of 10%. We know that it's a semi-annual coupon bond, semi-annual. So we know the M in the formula is 2. M that represents the frequency of compounding. Whenever it's semi-annual, M is 2. Okay? And then we know the YTM is 12%. So we'll first calculate the periodic coupon payment, the magnitude of the payment that bondholders get. So we have coupon rate times the par value over M. Coupon rate is 10%, and the par value is always 1,000 in this class, and M is 2 for this problem. So each period, every 6 months, bondholders will get $50. And the N that we'll use in the calculations is number of years times M. So we have a 7-year bond, and M is 2. So we'll have 14 6-month periods. Okay. And the R, the final piece, R is YTM over M. So R is the periodic discount rate. So YTM is given at 12%. We know it's a semi-annual bond, so M is still 2. So R that we'll use is 6%. So if we represent this on a timeline, it would look something like this. So even though it's a 7-year bond, we want to do the calculation in 6-month periods. So it'll go up to 14 periods. Okay? So if you want it to be specific about the units, it will be 6-month periods instead of years. Okay? And each cash flow, each payment is $50. And at the end of the bond, when the bond matures in 7 years, the bondholders will get paid the principal payment, the par value or the face value, $1,000. So based on this, what is the price of the bond? Price at time 0 is what? Okay. So we have all the components that we need, right? First, I'll break this down into 2 different types of cash flows. We have an annuity component. This is a regular annuity. Okay. And the cash flow that remains is the $1,000. This is a one-time cash flow. We'll call this the lump sum cash flow. Okay. So the present value of this entire deal is then the present value of this annuity plus the present value of the lump sum component. So expressed formally, then P0 is PV of the coupon payments plus the present value of the par value or the face value. So again, P0 is just the present value of the coupons. So we'll use the PVA formula, present value of an annuity formula, which looks like this. 1 plus R to the N plus, we'll get the present value of this par value, par over 1 plus R to the N. Okay. So again, just to show you, this is the present value of an annuity formula, and this is the PV of a single cash flow, lump sum cash flow formula. Okay. So we have all the inputs ready already, right? The annual coupon payment, they're $50, and we had it calculated up here, and we know the N, okay, number of periods, 14 6-month periods, and the annuity is for 14 periods, and the R is 6%. So we just plug the numbers in. P0 is then 50 over 0.06 times 1 minus 1.06 to the 14th power. It's not 7. Plus the $1,000 over 1.06, again to the 14th power. The cash flow of $1,000 occurs in year or period 14, and we want to go back to time 0. So there are 14 discounting periods. Okay. That gives us $907.05.